Here is your science news update for January 22nd. Let's dive right in. Okay, so today we've got some huge stories. We're talking about building viruses from scratch to take on superbugs, creating a type of concrete that actually eats carbon, and we've got a front row seat to what triggers those massive, explosive solar flares. It's going to be a good one.
First up, let's talk medicine. We've got a couple of developments that are, honestly, pretty game-changing. They could completely change how we go about treating some of the most stubborn diseases we face.
So here's the deal. For years, we've been in this escalating arms race with superbugs, right? And lately, it feels like they're getting the upper hand. But scientists are now turning to one of nature's own weapons to fight back.
And that weapon is something called a bacteriophage. You can just call them phages. Basically, they're viruses that hunt and destroy bacteria. And now, researchers over at New England Biolabs and Yale are figuring out how to build these phages from the ground up, synthetically. And this process is just wow. Think of it like this. You start with a digital DNA sequence, a blueprint. Then you assemble the virus's genome from synthetic bits of DNA. You pop that genome into a safe lab bacteria, and voila, you get a brand new, fully engineered bacteria killer. It's like programming a tiny biological missile to seek and destroy specific superbugs. And what's really wild is that this whole thing can be done in a matter of days, not the months it used to take.
Okay, staying in the medical world, let's shift gears a bit. We're now looking at how to improve the quality of life for folks living with HIV. Now, antiretroviral therapy, or RAT, has been a total lifesaver. But it's not without its challenges, especially when it comes to long-term side effects. And this is where it gets really interesting. Scientists have been looking at a surprising compound to help out. We're talking about very, very low doses of THC, so low they're non-intoxicating. A new study is showing that these microdoses have some pretty amazing benefits. They can improve the gut microbiome, which helps with mood, they protect the litter from damage, and they even lower chronic inflammation system-wide. And crucially, they do all this without getting in the way of the actual viral suppression. It's a pretty big deal. All right, let's zoom out from medicine and look at the bigger picture, the planet. We're going to dive into how science is coming up with some seriously innovative solutions to our biggest environmental challenges. And we're starting with one of the world's absolute biggest sources of emissions. Yeah, I'm talking about concrete. It's literally the foundation of our modern world, but making it creates a massive carbon footprint. But check this out. Researchers at Worcester Polytechnic Institute have developed something totally different, a radical new alternative they're calling ESM, or enzymatic structural material.
And when you compare the two, the difference is just staggering. I mean, look at this. For every single cubic meter of traditional concrete, you're pumping about 330 kilograms of CO2 into the atmosphere. This new ESM material, it actually removes over 6 kilograms of CO2 from the air. It's not just carbon neutral, it's carbon negative. This isn't just a lab experiment either. As Nima Rabar from the Institute says, it's a practical, scalable alternative. This kind of tech could completely transform the construction industry, especially in situations like disaster relief, where you need strong materials and you need them fast. Okay, so from construction materials, we're going to move on to something a little more delicate. It's another awesome innovation inspired directly by nature. So, let me ask you, have you ever looked at a butterfly's wing or a hummingbird's feathers and wondered where those incredible, vibrant, shimmering colors come from, especially since there's no pigment involved? Well, the secret is something called structural color. It's not about pigment at all. Instead, there are these teeny tiny nanostructures that reflect specific wavelengths of light. It's physics, not chemistry. And now, get this. Scientists at MIT have created a handheld laser device that can actually recreate this effect. They can paint with light onto a special film, creating these durable, iridescent colors. The possibilities here are pretty wild. Think adaptive clothing that changes color, or super-sensitive new sensors. All right, now let's turn our gaze from the Earth up to the sky. We're heading out to our very own star, the Sun, where a really recent observation has just cracked a long-standing cosmic mystery. So we've all seen pictures of solar flares, right? These massive explosions of energy. We've always known that they happen, but the big question has always been, how? What's the exact trigger that sets them off? It's been surprisingly tricky to figure out. Well, the key to the whole thing is a process called magnetic reconnection.
So imagine the sun's magnetic field lines are like a bunch of rubber bands. They get twisted and tangled up, and when the tension gets too much, they snap and violently reconnect. That snap releases a ton of energy. But as it turns out, it's not just one big event. Thanks to data from the solar orbiter, we now see it's more like a magnetic avalanche. It's not one big reconnection that starts the flare. Instead, it's a chain reaction of smaller reconnections. One little one happens, which triggers another, and they all build up and cascade into this massive, explosive discharge. And this avalanche process is what flings particles out into space at just unbelievable speeds. We're talking up to half the speed of light. That's what we call space weather. And it's that flood of high-energy particles that can cause real problems for us here on Earth, affecting everything from satellites to our power grids. As one of the ESA scientists said, these observations basically unveil the flare's central engine. You know, figuring out this trigger mechanism is a huge step forward. It's absolutely critical if we want to get better at predicting these powerful solar events before they happen. And hey, while we're on the topic of space, it's been another busy stretch for launches. SpaceX had a successful Falcon 9 launch, putting more Starlink satellites into orbit, and they've got another one scheduled to boost the U.S. Space Force's GPS network. So yeah, things are always moving up there. So there you have it, from the absolute smallest scales of molecular biology all the way out to astrophysics and our sun. It is just abundantly clear that the pace of discovery is not slowing down. It's actually speeding up. And that is your science news update for today. We'll be back in 24 hours with all the latest breakthroughs. If you found this useful, hey, you know what to do. Please like and subscribe. Thanks for joining us.